Right, another past examination question. So this is from Edexcel. It was a core mathematics C3 question from the year June 2008, and this is question number 5 of that paper. So let's have a read. So part A, given that sine squared theta plus cos squared theta is equal to 1, show that 1 plus cot squared theta equals cosec squared theta. So let's have a look at this question. So let's think about how we're going to do this one. So let me try part A over here. So we have to start from sine squared theta plus cos squared theta is equal to 1. So let me write that down for starters. So sine squared theta plus cos squared theta is equal to 1, and somehow we need to show that 1 plus cot squared theta is equivalent to cosec squared theta. Now if you're unaware of these ratios, so let me briefly talk through them. So there is a ratio for cosec, and remember cosec is 1 over sine. So 1 over sine theta gives us cosec theta, okay? And there is another ratio for cot. So cot theta is the same as the reciprocal of tan theta, or 1 over tan theta gives us cot theta, or cot theta is cos theta. Whoops, so let me be as neat as possible. So cos theta over sine theta. Okay, this is the reason for this is because remember tan theta is sine over cos. So let me be as neat as possible. So sine over cos theta. So sine over cos gives us tan, and if you calculate 1 over sine over cos, you'll get cos over sine, and cos over sine is cot theta. 1 over tan is cot theta as well. Now, why did I make these notes? So let me keep these extra notes outlined in red over here. I made these extra notes, especially this note over here, because if we divide through by sine squared theta, so if we divide through this equation or this identity here by sine squared theta throughout, since cos over sine is cot, that would make cos squared over sine squared cot squared, and also 1 over sine is cosec. So if I'm dividing throughout by sine squared, that would make 1 over sine squared, okay, bearing in mind this relationship, cosec squared. So let's go with the plan. Let's divide this identity here throughout by sine squared theta. So I'm going to say by dividing, and let me name this identity 1. So by dividing 1 by sine squared theta. So let's have a look at what we're going to get. So we're going to have sine squared theta. So let me write down all of the steps. Divided by sine squared theta. Plus cos squared theta, so cos squared theta divided by sine squared theta, and that is equal to the 1 on the right divided by sine squared theta. So I've divided throughout by sine squared theta. Now as you can see, I can cancel this sine squared on the top by the sine squared below. So I'm going to have 1 plus, and cos squared theta over sine squared theta. Let's rewrite that as cos over sine theta. Let's keep that in a bracket and let's square that bracket. So I'm sure that you guys would agree that this is the same as this, and that is equal to 1 over sine squared theta. Let's rewrite that as 1 over sine theta in a bracket squared. So I'm sure that you would agree that this and this is the same. Now let me make this point that I've made earlier. Now since cos theta over sine theta is equal to cot theta. So I went through that point earlier in red. And since 1 over sine theta, so 1 over sine theta is equal to cosec theta. So bearing in mind these relationships, we can rewrite this above equation as 1 plus cos theta over sine theta is cot theta. Don't forget the square, so it's a cot squared theta. And that is equal to 1 over sine theta is cosec theta. Don't forget the square, so it's a cosec squared theta. So this is exactly what we need to show, so as required. So that concludes part A. Let's have a look at part B. So here's part B. Let me try part B here. Solve for angles theta between 180 degrees and 0 degrees inclusive. The equation 2 cot squared theta minus 9 cosec theta is equal to 3. Given our answers to 1 decimal place. So let me copy down this equation. So we got 2 cot squared theta minus 9 cosec theta is equal to 3. Now, to solve equations of this type, so we look at the term with a power 2. So any equation with a power 2, so we're looking at this cot squared term, and we need to make this term to the power 2 as in terms of the least powered term. So the least powered term is cosec. So what I'm trying to say is we need to write the term to the power 2, which is cot, and we need to write it in terms of the term of the least power, which is cosec. So in other words, writing a cot squared as a cosec squared term. Now this is where this identity comes into play from part A. So with the aid of this identity, I can make this cot squared theta term in terms of cosec squared theta. So let's use this very identity. So back to my favourite colour blue. So by using this identity, so 1 plus cot squared theta is equal to cosec squared theta. So let me rearrange this identity for cot squared. So cot squared theta, if I take the 1 to the opposite side, I'm going to get cosec squared theta minus 1. And as a consequence of this rearrangement, let's replace the cot squared by cosec squared theta minus 1. So if I do the replacement, I'll have 2 outside. Cot squared theta is cosec squared theta minus 1. So let me do that replacement. Minus the 9 cosec theta, and that is equal to the 3 on the right hand side. And let's get rid of these brackets. So if I multiply, 2 into cosec squared theta is 2 cosec squared theta minus 2 into minus 1 is a minus 2 minus the 9 cosec theta, that is equal to 3. Now let me form a quadratic in terms of cosec. Let me take the 3 to the left hand side to give me this quadratic. 2 cosec squared theta minus the 9 cosec theta minus 2 minus 3 minus 5, and that is equal to 0. Now you don't need to do this. You can solve this equation in terms of cosec, but what I tend to do is I use a substitution. So I'll take a letter T, for example, a substitution, and I let T equal cosec theta as I have terms involving cosec. Okay, and if I use this substitution, my quadratic becomes 2t squared minus 9t minus 5, and that is equal to 0. So this is the equation that we'll get as a result of this substitution being used. So the plan here is we need to find the t values first, and once we found the t values, we'll substitute them into the substitution in order to find the angles later. So let's see whether I can factorize this quadratic. Let's see whether factorization is possible. So if I were to factorize, let's have a look. So if we have minus 5 here and a plus 1 here, let's do a double check. So 2t times t is 2t squared, so we have 2t squared here. 2t times minus 5 is minus 10t, minus 10t, and 1 times t is plus 1t, so minus 10t plus 1t is minus 9t, and plus 1 times minus 5 is minus 5. So these two would be the factors, and as a result of the factorization, we have two answers for t. Either 2t plus 1, so let me make it clearer, plus 1 is equal to 0. If I take the 1 to the opposite side, that would make 2t minus 1, and if I continue along, that would make the t answer minus 1 over 2. So that is one of the answers for t. Or t minus 5 is equal to 0, and if I take the minus 5 to the opposite side, that would make t, the other answer of t, plus 5. So here are the values of t. Let's put these values into the substitution for t. So since t is equal to cosec theta, let's firstly see what happens when t is minus half. So when t is equal to minus half, when I replace into this substitution, we'll have cosec theta, and that is equal to the t value being minus half. Now, unfortunately, we don't have a cosec button. Well, I certainly don't in my calculator. But remember, cosec is the reciprocal of sine. So 1 over sine theta gives us cosec theta. So bearing that in mind, 1 over sine theta is equal to minus half. And if I rearrange this, we're going to get sine theta, and that is equal to minus 2. So that is one of the equations for theta. Now, bear this in mind, everyone. Now, bear in mind the fact the range of sine lies between 1 and minus 1. So bearing in mind the range of sine, that would make this equation impossible to solve, or this equation will be undefined. So I'm going to indicate that with a cross. Okay, so just to repeat, sine theta has a range between plus 1 and minus 1, and bearing in mind this equation reads sine theta equals minus 2. This equation is undefined, hence this cross that I've used beside this equation. So we cannot solve that equation. So let's have a look at the other answer for t equals 5. So if I replace that in my substitution, so when t is equal to 5, so I want to replace cosec theta is equal to 5. Remember, cosec is 1 over sine, so 1 over sine theta is equal to 5. And if I rearrange this in terms of sine, I would have sine theta being 1 over 5. Now, looking at this range, it is possible to solve this equation, and I'm going to solve this equation with the aid of a cast diagram. So let me show you how to solve this using a cast diagram. So the equation that we need to solve is sine theta is 1 over 5. First thing to note is that my sine theta in this equation is positive, since I see a plus 1 over 5. So to work out theta, theta is going to be the inverse sine of 1 over 5. And we need our angles in degrees to 1 decimal place. So let me work this out in degrees. So if I take my calculator, inverse sine 1 over 5, and I get 11 point, let's say 11.54. So 11.54. So I'll round to 1 decimal place as instructed from the question right at the end. So we have 11.54 degrees. And as I said, let me use the cast diagram to help me work out the other solutions. So if I draw a quick cast diagram, so here's my circle. Let me divide it into 4 quadrants. And let me be as neat as I can with this cast diagram. So here are my 4 quadrants. So let me pick up my favourite colour, blue. So let me label them A for all, S, T and C. So remember, when it comes to the cast diagram, A means all, so sine, cos and tan only of any angle between 0 here and 90 is positive. S meaning sine, so sine is only positive for angles between 90 and 180, which is here. Cos and tan are negative in this quadrant. This quadrant is labelled T because tan is positive for angles between 180 and 270, and therefore sine and cos is negative in this quadrant. And this final quadrant, in the 4th quadrant, it's labelled C because only cos is positive for angles between 270 and 360. And tan and sine, however, are negative in this quadrant. So looking at this equation here, we need to plot 11.54 degrees where sine is positive. So sine is positive in the 1st and in the 2nd quadrant. Now we need to plot the angle from the horizontal. So measuring from the horizontal in this 1st quadrant, so from the horizontal, 11.54 degrees is roughly this line here. So just a rough judgment. So here's 11.54 degrees in the 1st quadrant, in the quadrant labelled A. And 11.54 degrees in the sine quadrant. So again from the horizontal. So this is the line representing 11.54 degrees in that very quadrant. Now we've annotated the angles on our cast diagram, but let's remind ourselves we need the solutions between 180 and 0 inclusive. So looking at this diagram and also bearing this in mind, positive angles are measured. So positive solutions or angles are measured from the 0 degree line in the anti-clockwise direction, and for negative solutions we're measuring them from the 0 degree line in the clockwise direction. Now we're looking for positive solutions, so our range is from 0 to 180. So that is, we're looking for positive solutions for theta. So we don't need to go clockwise when it comes to the cast diagram. So let's go anti-clockwise then. So the first positive solution, let me call that theta 1. So let me take my red pen, is from the 0 degree line in the anti-clockwise direction until we hit that first line on our diagram. And that angle, as you can see, is 11.54 degrees. So that's the first solution. Now we can calculate another one. So another one, which I'm calling theta 2, will be, and if I take a green pen, from the 0 degree line in the anti-clockwise direction until we strike that second line on our diagram. So if I go back to my favourite colour blue, so the angle from here to here, so bearing in mind this acute angle of 11.54, so that would be the angle in a straight line 180 minus this acute angle of 11.54 degrees. And if I do that calculation, so 180 minus 11.54, we get 168.46 degrees. Now let's have a double check of this range given. So we're looking for angles theta between 180 and 0, and we stop there because if we were to calculate one more would be, so if I take a purple colour pen, one more would be from the 0 degree line in the anti-clockwise direction, since we're looking at positive angles, until we strike that first line again on our cast diagram. So that angle would be 360 plus 11.4, and that angle as a result would be outside our given range, so that will be way beyond 180, so there's no need to work out that solution. So let's get rid of that. But I'm just giving you an idea of how this cast diagram works, or maybe a reminder of how this cast diagram works for some. So all in all, we got two solutions, but let's double check with the question though, because we need our answers, bearing in mind, to one decimal place. So if I go back to my favourite colour blue, let's round to one decimal place. The first one to one decimal place is 11.5 degrees. So that's the first one. The next one to one decimal place is 168.5 degrees. So here are our two solutions for theta to one decimal place for this very equation here. So that completes part B, and that completes the question in its entirety. So I hope you enjoyed this video. If you did enjoy the video, be sure to like and subscribe. Now, if you're unaware of the principles being used to solve this question, I have created videos in the past on this channel, and I provide links to those videos in the description below. So look out for those videos, so do check them out. It has explanations of the methods involved, along with added examples, so that it would consolidate understanding. So be sure to check out those videos in the links below. Other than that, I hope you enjoyed the video, and I hope to see you again. Thank you.